Hello everyone, this is Sanjay Rathi. As you know, Johnson counter, that is also known as switch tail ring counter, is important topic for all competitive exams, especially for GATE, engineering services, HPCL, ISRO, DRDO, and so on. Now, in this session, we will get command over Johnson counter and we will compare Johnson counter with ring counter, as well as we are generating timing signal by using counter plus decoder. So what is the relation between Johnson counter, ring counter, and that what ring counter plus decoder? You will get idea about all these things. Now, first of all, ring counter. So what is the ring counter? Basically, it is a shift register, guys. Here we are using the D flip flop. This is the D first flip flop, then second and third, and then fourth one. Output of this flip flop will become input for the second, then input of this output of this will become input for second, and so on. Now finally that Q0 will become input for this one. What is the D flip flop? That is called what? Transparent flip flop. Okay, or simply what is the next state for D flip flop? That is the D3. So when suppose I am going to write about the D flip flop, first of all, then the QT plus 1, the next state, or sometimes it is known as Qn plus 1, will become D. Right? For example, D is 1. The next, when we are giving the timing signal, it will become what? 1. If it is 0, then it will become 0 on application of timing signal. Watch this. We are giving the same timing signal or same clock pulse, and that's why it is called what? Synchronous. Yes, synchronous, right? Now, ring counter. So first of all, we will get that we will get idea about the different states, and then I will give you the idea about what are the applications of this ring counter. Then you can get idea about Johnson counter. Then, if it is the ring counter, suppose we are going to start with what? 0, 0, 0, 1. Let this is the first state, right? So we are giving this input 0, 0, 0, and what? 1. Then Q0 will become D3. And then Q3 will become D2, Q2 will become D1, and Q1 will become D0. Means what is the serial input? Q0 is here 1. Now when we are giving the first clock pulse, this one is shifted, this 0 shifted here, this is shifted here, and this is shifted here. Means it is a right shift register. Then, and again there is a feedback also. Then this Q0 will become serial input. This is the SI means serial input, and that is the clock pulse. Now it will shift here after application of the clock pulse. This will shift here, this will shift here, and this will shift here. Okay. Then this again will become the serial input for the first flip flop. This is the first, this is the second, third, and fourth. We can say, no doubt Q3 is given, so you can write like this: third, second, first, and 0, and so on. Then this 0 is shifted here. This 0 here, this 1 here, that 0 here. Again, this will become input 0, 0, 0, and 1. Now, we have started with what? 0, 0, 0, 1, and again it is a 0, 0, 0, 1. So there is repetition. So after fourth clock pulse, there will be repetition. Means again you will get this one is shifted here. Now this 0 is shifted here. This 0 will become input 0, 1, 0. Then again you will get, and after that again there is a repetition. Okay guys, so this will become 1, and now this one is shifted here. Now you have to focus on this one. Focus on this side. We are having the 4 different states. First one is 1, 0, 0, 0. Second one is 0, 1, 0, 0. Third one is 0, 0, 1, 0. Fourth one is 0, 0, 0, 1. We are getting the 4 different states, and then after that there is a repetition. So we are using the 4 flip flops. We are getting the 4 different states. If you are using the 3 flip flop, then you will get the 3 different states. Means if there are n flip flops, then you will get n different states. What is the use of this? So we are using this for timing signal. So what is the meaning of that timing signal? Means suppose we are using some device, number of devices here, first one, second, third, and fourth. Okay, So one by one we want to make it what? Enable. So we are using this device, ring counter. It is connected here, first one. Then second, third, and what? Fourth. These are called timing signal, T3, T2, T1 and T0, and that is the ring counter, guys. So when it is 1, what about the all other? 0. And that's why this device is enabled and all other are disabled. After one clock pulse, this will become 0, 1, 0, 0. So it will enable and other will disable. So these are used to generate what? Timing signals. Okay. Now this, so similarly we can say at a time one device will be enabled. For example, the clock pulse is what? 10 seconds. Then this device will be enabled for 10 seconds. Then after 10 seconds, that second device. Then after 10 seconds, the third device. Then after 10 seconds, the fourth device. So we can generate like this. अब आते हैं, what are the disadvantages of this ring counter? Disadvantage is what? We are using the 4 flip-flop and we can generate only what? 4 timing signals. So inefficient, right? Right. When we are using the Johnson counter, you will get idea that we are using the 4 flip-flops and we can generate what? 2n, means 8 timing signals, guys. But what is the simplicity? No need to use any decoding gates. At a time one is enabled, directly no need to use any gates. This is enabled, all other are disabled. This is enabled, all other are disabled. So at the end I will compare the ring counter with the Johnson counter. Okay, so that is the use of this. Then second disadvantage, we will get the idea at the end. What is the locking? Right? So what is the locking? What is this problem? At the end we will get idea. Now about the Johnson counter. When we are using the Johnson counter, then this is also known as a switch tail ring counter or what? Johnson counter. What is the difference here? This will become input for the second one, next one, and that output will become input for the next. Up to this point everything is fine, but here this is not the input. Q3 bar is the input for the first one. Okay, so there is a change. Now because of this change, again this is a shift register and we are giving the same clock pulse here, means it is a synchronous counter. Okay, it is a shift register, again right shift. Now to write down the outputs, that is the, like we can start with what? 0, 0, 0, 0. Now what is the input here? It will become what? Q3 bar. So Q3 bar means what? You can change like this. 1 minute. Q0, Q1, Q2 and what? Q3. Okay. Now this is become what? Q3 bar here. Because according to diagram we have to, that is that Q3 bar will become the input. And now watch this. This Q3 bar will become, this is the Q3 bar will become what? 1. Then 1 shifted here, 0, 0, 0. Again this is 1 serial input, 1. This is 1, 0, 0. This will become 1, 1, 1, 1, 0. This will become 1, 1, 1, 1, 1. Now this 1 will become 0 because it is inverted. Then it will become 0, 1, 1, 1. Then again it will become 0, then 0, 0, 1, 1, then 0, 0, 0, 0, 1, and then it will become 0, 0, 0, 0, 0, guys. Means after 8th clock pulse, right, it will repeat. Again you will get 1, 0, 0, 0 here, and after that there is a repetition. Means we are having the 8 different states. 8 different states for this one. So here, if suppose we are using the 4 flip-flops, then how many number of states? 8. Or in ring counter we are using the 4, means we are getting the 4. If you are using the 3, then it will be 6 and so on, double. Now guys, watch it carefully. We are getting at a time single one. For example, in first case, it is all 0, 0, 0, 0, right? What is the second one? 1, 0, 0, 0. Third one, 1, 1, 0, 0. Fourth one, 1, 1, 1, 0. But in case of ring counter, at a time only single one. We are getting the single one. This was the, you can compare. In case of ring counter, 0, 0, 0, 1. This is the timing signal. 1, 0, 0, 0. Second timing signal 0, 1, 0, 0. Third timing signal 0, 0, 1, 0. At a time 1. That's why no decoding gates are required. But in this case, decoding gates are required to decode this. So at a time we want only single one, all other output should be equal to what? 0. To decode this, we are using a very simple decoding logic or AND gates. You can directly write like this. For example, for first, it is 1, 0, 0, 0. This is the first one. If suppose you are taking it as the first state, then second, then third, then fourth, then fifth, then sixth, seventh, eighth, right? Then you can write like this. Let this is A flip-flop, this is B flip-flop, this is C flip-flop, and this is let E flip-flop. Right? So A, B, C, E. I am not giving D because the name of general name is what? D flip-flop. I am giving it as a flip-flop. This is like B. This will become C and that will become what? E. And that's why this will become E and this will become E bar. This is C, C bar. B, B bar. And this is A and what? A bar. Now, what is the decoding logic here? If all are 0, you have to choose the last two. So it will become A bar, E bar. Directly. Right? Similarly, if all are 1, for example, in the fourth state, this is all are 1, then you can choose last two, this one and that one. It will become AE. You have to use the AND gate. Then, what is this? 1 is 0. Now, if this is not AND 0, then you can choose these two. This is 1, 0 means it will become AE bar, AB bar. Then this is 1, 0. It will become BC bar. This is 1, 0. It will become CE bar. Now after that it will become 0, 1. So what is the 0, 1 means? A bar B. Then this is to B bar C. And now this is to C bar E. Right? And now we have 1, 2, 3, 4, 5, 6, 7 and what? 8. Total 8 AND gates required, and with every gate with what? Only 2 inputs. With every gate with 2 inputs. So what is the basically a Johnson counter? If suppose you are going to design, so when we are going through this type of Johnson counter, right? So it is a used to generate timing signal, but at a time we want only single one and all other output should be equal to what? 0. So we are getting the 8 different states, but we have to decode it. Means finally I am giving you the diagram. For example, there are 4 flip-flops, right? Now this is the first one, second one, fourth one, third and fourth one. Now internally this is connected. And this is connected here, feedback. I am not giving you the clock pulse, just simple diagram. Here we have to use what? 8 AND gate. How many AND gates? 8 AND gate. One, two, three, 4, 5, 6, 7 and what? 8 AND gates. Then we have the 8 timing signal, guys. T7. And what is the input to the each gate? For example, for first gate the input is A bar, E bar. So where we are getting the A bar, E bar? This is the A, this is the A bar. So we have the A bar, we have the B, B bar, we have the C, C bar, and we have E, E bar. And that's why first input is A bar, E bar. So you can directly connect A bar and from that E bar. Similarly for the second one, A, B bar. It will become A, B bar. Right? Similarly for B, C bar and so on you can connect. So total 8 AND gates are required to generate timing signal. Now what will happen? At a time one T will be 1, all other T will be what? 0. So extra AND gates are required. How many AND gates are required? 2N. If suppose there are 4 flip-flops, then 2N means 8 AND gates are required to decode it. Or in ring counter, no AND gates are required because timing signal is what? At a time only 1 is 1. So no need to use extra hardware. But we are having only 4 timing signal for 4 flip-flops. So that is the difference between the Johnson counter and ring counter. So finally we can conclude here. If number of flip-flops is n, so in case of ring counter, how many states? N. Or in case of Johnson counter, it is 2n. But no extra gates are required in ring counter. Here extra gates are required. How many extra gates are required? 2 AND gates required, with every AND gate with 2 inputs only. With 2 inputs only. Whether it is a 3 flip-flop or 4 flip-flop or 5 flip-flop, always the input for the AND gate will be what? 2 only. Okay, that is the difference between ring counter and Johnson counter. Now, how we can generate the timing signal by using counter and what? Decoder. Yes, it is also possible. So counter and decoder means, if you are using the counter here, it is a 3-bit counter, right? So if it is a 3-bit counter, so it will count like this, what? 000, 001, 010, 011, 100, 101, 110 and what? 111. So what will be the output? 3 outputs terminal here. 1, 2 and 3. You can give any name, for example B2, B1, B0. This is the binary counter. We are giving the clock pulse. So that is the counting output of this. Now it is connected to a decoder. So decoder means there are 3 input to the decoder and we are having the total 8 output. D0, D1, D2, D3, D4, D5, D6 and what? D7. Now guys, what is the, if we are giving the 000, then what will happen? This decoder will decode and D0 will become 1 and all other will become what? 0. So that is, we are giving the timing, we are generating the timing. You can give the name like what? T0, T1, T2, T3 and T8. So this is the T0, T1, T2, T3, T4, T5, T6, T7. This is 1, all other are 0. Similarly, decoder will decode, this will become 1, all other will 0. And so on, you can say. This is the output of. So we are getting the timing signal by using what? We are getting the timing signal by using binary counter plus what? Decoder. 3 to 8 line decoder. Now guys, if suppose this question is given, how many flip-flops? In a 3-bit binary counter, 3 flip-flops are required. In this, 3 flip-flops are required and we are getting 8 timing signal. Means what? 2 to the power 3. General formula 2 to the power 3 timing signals. Timing signals. Suppose if you are using the n flip-flop, then it will become 2 to the power n timing signals we are generating. But remember, to decode this, we have to use what? One decoder. And in a decoder, what is the decoder? We are using the AND gates. So here, if suppose this is a 3 to 8 line decoder, means inside this decoder there will be 8 AND gates. Means how many AND gates is required? 2 to the power n AND gates are required, guys. 2 to the power n AND gates are required. AND gates are required. No. So same AND gates are required in case of what? Johnson counter also. So what is the difference between this and Johnson counter? In Johnson counter, 2 AND gates are required, but every AND gate with 2 inputs only. Here what will happen? 2 to the power n AND gates are required, and guys, if there are 3 inputs to the decoder with 3 inputs, with 3 input pins. If there are 4 input to the decoder, 2 to the power AND gates required with what? 4 inputs. 2 to the power 4 AND gates with 4 inputs. 2 to the power 5 AND gates with 5 inputs. So it depends upon this inputs. So when we are increasing the counting of this counter, input to the decoder will increase as well as input lines for AND gates will increase. So we can generate the timing signal by using ring counter, by using Johnson counter, by using what? This combination. Binary counter and what? Decoder. In case of ring counter, 4 flip-flops, 4 timing signals. Means n flip-flop, n timing signals. No extra AND gates are required. In case of Johnson counter, n flip-flops, 2 n timing signals, 2 n AND gates required with every AND gate with 2 inputs only. Or in case of this, if you are using n flip-flops, you will generate 2 to the power n timing signals. At the same time, you have to use 2 to the power n AND gates with every AND gate with what? How many output inputs? N inputs. If it is 3, then 3, 4, then 4, 5, then 5. So that is the case. So you can make a proper table for this. Watch this session 2 or 3 times. These 3 topics are very, very, very important, and you can compare all these things. Normally, we are not having the idea about what decoding logics for Johnson counter and this combination. If you find any difficulty, guys, please comments on comments box, right? And if you want to give any suggestion, then again you can give the suggestion. Just I am giving you some assignment how this topic is important. In a GATE exam, we are getting this question. To try to solve this question on shift register, a 4-bit shift register circuit configured for right shift operation, right? Now D in will become A, right? A will become B, then B will become C, C will become D, and so on. And here XOR gate is used here. If the present state of the shift register is 1101, the number of clock cycles required to reach the state A, B, C, D is equal to what? 1111 is. Very, very, very simple question. So try to solve this question. Use the same concept. You have the idea about the XOR gate, guys. Okay. So suggest कीजिए. And what is the logic behind this? Is suppose you want to solve the number of questions, right? First of all, go through the syllabus. Right, I am going to take one session important for that, where I will give you the overview of the syllabus. Means I am going to give the definition of each topic for that. Okay, after that, try to solve the previous year question, get the idea about the which type of previous year questions, and guys, then get the command over important topics. Right, for example, I have given you the idea about the Johnson counter. So what is the Johnson counter, what is the ring counter, and what is the counter plus what decoder, and what is the difference between these 3, each and everything about this topic. You have any question, then please pin me on comments box. So like the session and subscribe my channel, guys. So thanks for attending the session. Stay tuned with me. Thank you.